let's just continue with the other part. I welcome you back to the page. So let's just go on. Let's take question 6. So a student determines the density of an irregular shaped stone. The stone is slowly lowered into a measuring cylinder partly filled with water. So we can see that it's partly filled with water. Which other apparatus does the student need to calculate density of the irregular shaped object? So yeah, I'm going to get the volume. I'm going to get the volume of the stone from here. Volume. So to get density, to calculate density, I need two quantities. That's the mass. Density is actually mass per unit volume. So this will provide me with the volume. So to find mass of this stone, what instrument do I need? I don't need a thermometer. Thermometer is used for measuring temperature. Meter rule is used for measuring length. Stopwatch is used for measuring time. So a balance is what we use for measuring what? Mass. So the answer is A. Let's go on. Okay. Question 7. A train is traveling horizontally in a straight line. A book on a table in the train. The diagram shows all the forces acting on the book. Okay? This is the table. Okay? How is the train moving? How will I know how the train is moving? I can see that, that there's frictional force here. That means the book is moving in this direction. Did you get that? So the frictional force always acts in opposite direction. But then you need to, how is the train moving now? To think about that, if the train, let's say you have the train like this now, this is the train. If the train and this book and this table are moving at the same speed, they would have been moving in the same direction. But think about it, when you have a car, when you move your car in the morning, and the car is moving this way, and you are the passenger here, how do you move? You move backward. You feel the force. That tells you that the car is moving faster than you. It's accelerating faster than you. So you move backward. So, and I know that friction opposes motion. So if friction is moving this way, it means the book is moving backward. That means the train is moving forward. Did you get that? So the correct answer here is it's actually moving to the right, then it's accelerating. It's accelerating and moving to what? The right. So the correct answer is B. The diagram shows 4 bars, 4 beams, each of negligible weight and freely pivoted. Which of the beam is not in equilibrium? I take the question again. The diagram shows 4 beams, each negligible weight and freely pivoted. Which beam is not in equilibrium? So we need to remember that for a beam like this to be in equilibrium, resultant moment must be 0 and resultant force must be 0. So I want to believe that the resultant force is actually 0 for it to be balanced. So the only thing we need to check now is if the resultant moment is 0. So how do we do that? Find the moment of this turning and this. So this is 6 Newton meter anticlockwise, and this is 6 Newton meter clockwise. So resultant moment equals to 0 means clockwise must be equals to anticlockwise. So this is balanced since the anticlockwise moment equals to the clockwise moment. So this is balanced. So we are looking for the one that is not balanced, not in equilibrium. So this can't be my answer. Let's check out for this. Turns this way, turns this way. So of course, in fact, same force, same distance. Then one is anti-clockwise and the other is clockwise. So this is 12 Newton meter anti-clockwise, and this is 12 Newton meter clockwise. If you do for all others like that, so if you do for this, we are going to have 3 Newton meter anti-clockwise, and this will be 6 Newton meter clockwise. Already I've seen the one that is not equal, but let me check for this. This is 8 Newton. This is 8 Newton meter, and this is 4 Newton meter plus 4 Newton meter. So this is also what? 8 Newton meter anti-clockwise equals to 4 Newton equals to 8 Newton meter clockwise. So the only one that is not equal is this, and actually that's the one that is not in equilibrium. Is that okay? So I may have to rub off all this so that you can clearly see the answer. So what's our answer there? Our answer is C. So our answer is C. So let's move on. So, question 9. An object of mass 1.2 kilogram is moving with a velocity of 2 meters per second. When it is acted upon by a force of 4 Newton, the velocity of the object increases to 5 meters per second in the same direction. For which period of time does the force act on the object? So I can think about it in 2 ways. Is that I think about it as I can see change in momentum here. So I can say impulse is equals to change in momentum. If you remember this, impulse change in momentum theorem says that impulse equals to change in momentum. So I can basically just do this and get my answer such that I'll just do this. I'll say this is 1.2 into the bracket of 5 minus 2 divided by 4. So that gives me what? 1.2 multiplied by 3 divided by 4. I think that gives me 0.90 second. Yeah. Alternatively, you can still do it this way. You can just say force is equals to MA. So my A is equals to force divided by mass. And that gives me what? That will give me 4 divided by 1.2. So let me take a calculator up here. So you can just do 4 divided by 1.2. So that gives us 3.333. So this is 3.33 meters per second square. So, and I know that acceleration is equals to v minus u over t. So doing that, it means that 3.33 is equal to what? What's my v? 5 minus 2 over t. So my t is equals to 3 divided by 3.33, and that's equals to 0.90 second. Do you understand that? So the answer, the correct answer here is A. But whichever way you have done, you're still going to get the same answer. Okay, let's move on. Which rule about the change of energy in the energy store must be correct? So A, water pumps up to a high altitude dam. Pumps up to a high altitude dam. Energy store. Take note, energy store. You need to take note of that word, energy store. And gravitational potential energy of water, said energy store, gravitational potential energy of water increases. Okay, I'm coming to that. Water pump up to high altitude dam, kinetic energy of the water. Is kinetic energy ever stored? No. When we are talking about stored energy, we are talking about potential energy. Did you get that? So immediately I'm saying kinetic. Anyway, I'm saying kinetic, they are off already. B is off, and then D is off. Am I communicating? Now, air passes through wind turbine. This one is even out of it, because when air passes through turbine, it's going to be moving, so kinetic energy increases. So that's why this is also wrong. But this one, you need to remember that as height increases, gravitational potential energy increases. Since GPE, gravitational potential energy equals to mgh, m is constant, g is constant. So the major factor there is height. As the height increases, gravitational potential energy increases. So the correct answer here is A. Do you understand? Let me just take this to 13. Let me just take it to 13 so that the next video we are going to continue. I have to make it this way because I have to explain every single thing that we do. So normally if you are just to pick the answer, if I'm just to show little workings and just give you the answer, we should be able to do this paper in 30 minutes, although the allocated time is 45 minutes. Now, let's take question 11. A woman's mass is 50 kilogram. A woman of mass 50 kilogram has 81 joules of kinetic energy. What's the speed? So we need to remember that kinetic energy is half mv squared. So, and that implies that 81 joules is equal to what? Half multiplied by 50 multiplied by v squared. So at the end of the day, we are going to have v to be equal to square root of 2 multiplied by 81. 2 multiplied by 81 divided by 50. And that will give us 1.8 meters per second. So the answer is C. Okay, let's take question 12. Question 12. A child runs up a set of stairs 4 times. The time taken for each run is recorded. Which time is measured when the child's useful power is greatest? We want the greatest power. Which time is measured when the child's useful power is greatest? So we need to look at something there. If you look at power, what's the definition of power? Power is the rate of doing work. Power is work done over time. So let's analyze this. A child runs up a set of stairs 4 times. So the work is constant. The work that has been done is constant. So then we also need to know that power is inversely proportional to time. The longer the time, the smaller the power. The smaller the time, the higher the power. So this is what I'm saying. If I'm able to do 20 joules of work in 1 second, and another person is able to do 20 joules of work in 5 seconds, who has more power? I have more power because I have done 20 joules of work in lesser time. The smaller the time, the higher the power. So what's the correct answer here? The correct answer here is A. I hope this video has been helpful. Please do like this video. If you have not subscribed to my channel, please do subscribe. And if you have any question or you want me for a personal tutor, to be your personal tutor, you can contact me on the email I'm going to type above. The email is oksolomon@gmail.com. I will be waiting for you. The other part of this paper, I'm going to continue solving this paper. The next video will be from number 13 to wherever we can stop. So see you in the next video.